Hello student, today I am going to start the chapter 13 of WBBSE board mathematics. The name of the chapter is variation. In this chapter, variation, we first discussed about the variable and constant and the types of variation. Variation. In case of variation, there are two terms. One is variable and another is constant. What is variable? Variable are the quantities whose values are changed with respect to the other. Now, what is constant? Constant are those quantity whose values are fixed. Variation are three types. Number one is simple variation. As for example, x proportional to y or y proportional to x. Number two, inverse variation. As for example, x inversely proportional to y or y inversely proportional to x. And number three is joint variation. In case of joint variation, let A, B and C be three variable quantity such that A proportional to B when C constant and A proportional to C when B constant. Then we can write A proportional to BC when both B and C vary. Now we can discuss about some properties of variation. There are 7 properties. Number one, if A proportional to B, then B proportional to A. Number two, if A proportional to B and B proportional to C, then A proportional to C. Number 3, if A proportional to B, then A to the power n proportional to B to the power n, where n is equals to positive whole number. Number 4, if A proportional to BC, then B proportional to A by C and C proportional to A by B. Number 5, if A proportional to B, then AC proportional to BC, where C is either variable or non-zero constant or constant. Number 6, if A proportional to B and C proportional to D, then AC proportional to BD and A by C proportional to B by D. And the last one is 7. If A proportional to B and B proportional to C, then A plus minus B is proportional to C. It is number A, and number B, AB proportional to C square. Now let's prove the properties. Number 1, if A proportional to B, now we can write A is equals to KB, where K is equals to non-zero variation constant within bracket. That is, B is equals to 1 by K A. So we can write B proportional to A, where 1 by K is a non-zero variation constant. So the problem is proved. Number 2, if A proportional to B and B proportional to C, then you can write A is equals to K1B and B is equals to K2C, where K1 and K2 are the non-zero variation constant. So we can put the value of B in case of first A is equals to K1B. So A is equals to K1 K2 C. That is A proportional to C, where K1 and K2 are non-zero variation constant. That is the second properties are proved. Number 3, if A proportional to B, then A is equals to KB. Therefore, A to the power n is equals to KB to the power n. That is, A to the power n is equals to K to the power n, B to the power n. So you can write A to the power n is directly proportional to B to the power n, where K to the power n is also a non-zero variation constant. Proved. Number 4, A proportional to BC. Therefore, we can write A is equals to KBC. So we can write B is equals to A by C into 1 by K, that is 1 by K into A by C. That is B proportional to A by C, where 1 by K is a variation constant. Again, we can write C is equals to 1 by K into 1 by A by B. That is, C is directly proportional to A by B, where 1 by K is a non-zero variation. So the problem B proportional to A by C and C proportional to A by B is proved. Now number 5, if A proportional to B, therefore we can write A is equals to KB, where K is equals to non-zero variation constant. Multiplying both sides by C, AC is equals to KBC. That is, AC proportional to BC. Proved. Number 6, if A proportional to B and C proportional to D, then A is equals to K1B and C is equals to K2D, where K1 and K2 are non-zero variation constant. This one is number 1 equation and this one is number 2 equation. So from equation 1 and 2, we get AC is equals to K1B into K2D, that is K1 K2BD. So you can write AC proportional to BD, where K1 K2 are non-zero variation constant. Again, from equation 1 and 2, we get, that is, we divide A by C and in left hand side, and K1B divided by K2D in right hand side. That is, A by C is equals to K1B by K2T. Then we can write AC proportional to BD, where K1 by K2 is a non-zero variation constant. So both are proved. And the last one, that is property number 7. Here A proportional to B and B proportional to C. So we can write A is equals to K1B and B is equals to K2C. From this B is equals to K2C, we just substitute the value of B in case of here. So the values of A is equals to K1, K2C. This one is equation number 1 and this is equation number 2. Now A plus minus B by C is equals to K1, K2C plus minus K2C by C. C is equals to, therefore C is equals to K1, K2 plus minus K2 by C. Therefore we can write A plus minus B by C is equals to K1, K2 plus minus K2. This one also a constant, so we can write A plus minus B is equals to RC, where K1, K2 plus minus K2 is equals to R. So we can write A plus minus B proportional to C. Proved. And the last one, AB by C square, we just putting the value of A and B from equation 1 and 2, K1, K2C into K2C by, it is C square, so it is K1, K2 square. So you can write AB by C square is equals to P, where P is equals to K1, K2. That is AB is equals to P C square. So we can write AB proportional to C square. Proved.